So I'm going to be going over assignment 1. So briefly, we're inputting 3 files. We're inputting an English text file, German text file, and I chose Spanish. And then after that, we're going to go ahead and assign some labels to English being 0, German being 1, and then my third language would be Spanish, which would be 2. And then we're going to go ahead and sift through the data sets to make sure it's only including 5 letters. And then we're going to go ahead and pre-process it using this OR method. And then step 4 is the more exciting part, is actually where we're training and testing our data sets. So we have some specific instructions where we are going to be using actually like training data sets should be about like 80%, but then the second data sets should be the remaining like 20%. Then we're going to go ahead and split our data sets where that last 20% that I mentioned for my testing my data, we're going to only get the words that start with the last like few letters. And then we're actually going to use that for testing our data sets. Then we're finally going to train our model. And once we've trained our model, we're going to test it using our test data sets. And we're going to be using 3 specific models, the KNN, the SVM, and the MLP. Those are the 3 model sets. And we're going to be comparing its level of accuracy. We're going to do it by graphing them. And I'll show you what that looks like at the end. So, yeah. So we're going to go ahead and just use 3 languages. We're going to process it, and then we're going to use it just to train our models. Of course, with those data sets, we're going to split it to what's training and testing. And then we're just going to go ahead and, train our models, make some predictions, graph it, and just show the which model was the best for us. So I already ran this. I'll go ahead and run it again for this stake. I'm going to refresh it and run it. And so while that's doing it, what it's doing right now is running the imports. And because it's really fast, it's because I already ran it before. If it was my first time, it would take a lot longer. So very first thing is that we have to go ahead and we're defining a method called loading words, and it's expecting a parameter just expecting a parameter. And the idea of it is that it's the name of the file. And then we're going to receive that text file, we're going to encode it, and then we're going to return some set of array of words. And so I actually opened it, and I actually used the encoding, the Latin-1, to encode these 3 languages. So I imported the English, German, and Spanish text files, and I used the Latin-1 to encode it. And then, so here I have the words that is set to an empty array. So what the idea is that when I go and do a for loop for each line in the file, I'm going to go ahead and use this strip method, which helps to remove like the white spaces and new lines, and then store into Word, and then append that word into words, which is our empty array. And then once we're done with it, we're going to return words. So the idea of this is just returns the array of words. Then we're going to be, now to do that, this is just defining the function. We need to call it. So to invoke it, I just said, hey, this is the English words database. And then I called the loading words function, and passed the name of my file that I wanted to encode. So it would be the English .text. And this happens for the same for all of the other 2 text files. So I did the same thing for German and Spanish. Then in the instruction, it says to filter the words, and it should be only 5 letters, and then return the array that only contains 5-letter words. So it's exactly what I just did. I'm basically passing that words data set, and then I have a 5-letter empty array, and then we're going to go ahead and sift through that. For each word in the words data set, we're going to check its length to be 5. If it is, we're going to add that word to the 5 letters array, and then return that 5-letter array. Once that's done, we now reassure that all those words contain 5 letters. And we do so by calling the 5 letters filter function, pass in the respective datasets that we just went ahead and load them to. Pass that in. So now English words, German words, and Spanish words contain 5 letters. Okay, great. Then what we're going to be doing is combine all those 5 words together to a word called all words. So all words is a single variable that contains all the words of both English, German, and Spanish. And by then, at this point, they should only be 5 letters. Each word should be 5 letters, that is. Okay, so remember at the point when I mentioned for that, English is going to be set to 0 and German is represented as 1 and Spanish is represented as 2. That's just me saying that I'm just going to go ahead and create a label. So for whatever an English word appears, that is a label of 0. If a German word appears, that's a label of 1. And then same thing with Spanish, except it's going to be labeled with 2. So what I did is for the number of English words, I just multiplied to 0, and that's how many English words there are. And that's stored as English labels. Did the same as German and Spanish. And then I combined them just as I did with words, all into this called all_labels. Okay. So now this is me converting. So I have essentially a function here that it's called converting word to features, and I pass in a word. So the point of this is to convert the words into an actual numerical feature that's used by the ASCII, the ASCII, that is used by that. So once we call that, we've converted each word using this level of a conversion. And so let's go ahead and show you an example. So here, features. This features is a variable, and we're going to go ahead and whatever is inside of this set of parentheses is going to get converted to a NumPy array. And so we had to put this brackets because we're converting into an array. And then converting word to features. For each word, we're going to go do it for all features. For all words. So this is where we're calling the converting word to features to make sure that we've translated the words into a numerical features. Okay. Then we also reassured labels. We've set the labels, all labels, to make sure it's in a NumPy array, and we just call it labels. Okay. Finally, well, not necessarily finally, but next, we have 4 variables here. There are xtrain, xtest, ytrain, ytest. This is us splitting into the training dataset and testing dataset. According to the instructions, it said that the training dataset should have like 80%, and then for testing dataset, it should be about 20%. So we use the train test split to help us split between training data and testing data, and we pass in the features that we used here, the labels, having the test size of 0.2 because that's what was stated, the random to ensure that it's random, and then you stratify the labels. Now we're going to be playing with some models. So by playing, I mean training. So we have the 3 models here, and we're training them using the dot fit. That is what was training them. And we passed the 2 training data sets, the X and the Y. And we did this for each single one. Now, I do want to mention a couple of things. So one of the problems that I was facing when doing this is that when loading, it took me forever to actually train the SVM. And I find that if I change it to RBP or RBF, it's a lot faster. It's more efficient than my traditional one, which I believe I was using linear. This one, it compresses the time and it trains the model much faster. So that is worth noting. So I train all 3 models, okay? And by using the dot fit. Next, the idea is to make a prediction for each model. So to do that, I assign the predictions to each model by doing so the kn.predict, that's just a built-in method. We pass in the testing data so it can predict based on the testing data and store that into its respective predictions. Okay, that's great. But how accurate is that? Well, next we check the accuracy in terms of percentage. We grab the accuracy score here, which is just a method that was a built-in method. We pass in the Y testing, this is the 20% I was talking about, and we pass in its predictions that we just did. We pass in those two things to the accuracy score method, and that would give us the how accurate that each method was. Okay, great. So let's go ahead and multiply that by 100 to give it into a decimal format. This is me printing out the accuracy, and we can already see that K and N is the least accurate compared to SVM and MLP. Okay, so how does that look like in the graph form? Okay, well, models is going to be our X. Our Y is going to be representing our accuracies, which is the percentage that we just showed you here. We're going to just go ahead and graph it. And so I'm just going to, jump down here. This is just basically me putting into action. Okay, this is determining the size of my graph. This determines like how big my y will be, my y-axis will be. Tells me what's my x is labeled, what is my y is labeled, the title, and what is basically how we're gonna plot it. So the x will be our models, y will be our accuracies, and what's the color? I like to do purple, blue, and green. And then just for even better, I just added the number on top of each bar to make it even more easy. And then I attached a threshold that's at the 65%. Because in the instructions says we need to have a 65% greater of accuracy, and it's easier if I did a dashed line to represent that. So already you can see, like I said, the SVM and LPM this is the neural networks, specific one. So essentially, you can already see technically, all of them are actually pretty accurate. It's the K and N that's a little bit less accurate. It's at 85%. But the SVM and MLP is both a little bit higher in accuracy. But basically, they're all the same. And that's pretty much it. This is my comparison of model accuracy. And so we can just see off the bat that pretty much all three models are accurate. If I have to say, maybe SVM and LPM were a little bit more accurate. But yeah, that is it. Thank you for listening.